The question say that there is a function q, which means that q is the output while t is the input. Q depends on the value of t, and their relation is linear, that means form a straight line. At the same time, they say that the slope negative value here, so it's going downward, and this is the vertical intercept. So to rearrange q, we should say how many t and then plus how many. So how many t is at s natural log 3. This is the slope, and this is natural log out. That means when our input is 0, our vertical position, that means the vertical intercept, is this item, the constant term. Therefore, what they try to tell you is the slope equal to negative 0.1 natural log 9. That means s natural log 3 is equal to this value. Just simply change this one to 2 natural log 3. Then we get s natural log 3 is equal to negative 0.2 natural log 3. S is equal to negative 0.2. And the vertical asset is this one, which is the same as here. So we know that natural log 9 should equal to natural log r. 9 is equal to r. The line is like this with our input and output. And vertical intercept is natural log 9. But be careful, sometimes they may tell you the horizontal intercept. In those cases, then you put x equal to the intercept value, y equal to 0 into the equation. Now in part B, they give you another points of view of q. So q at the same time is equal to this item. And then we have to prove that n is equal to this. This is the relation between t and n, so we are going to combine them together. Natural log r is 9 plus s, that means negative 0.2. Natural log 3 times of t is equal to natural log 120 minus 3n divided by n. So it's easy calculation. In order to remove natural log, we have to put them all inside one single natural log. So by using the property, this is natural log 3 power negative 0.2t. Therefore, we can combine them. Natural log 9 times 3 power negative 0.2t and we find that 9 and 3 are somehow related, so we express in 3 power 2, so we have 3 power 2 and then together with negative 0.2t. This amount of n, and then we group all n terms together. Extract n, we have 3 power 2 minus 0.2t, and we have positive 3 here. But both terms, we have the factor 3, so we should extract 3 also. So power of 1 is left. That's why when we both sides divide by 3 and those items, it will become 40. Part 2, they say that is that possible that there are 3 million bacteria in the room during the experiment. N originally is defined as the number of million. So here they are talking about can n equal to 4. If n is equal to 4, then 4 is equal to 40 over 3 power of 1 minus 0.2t plus 1. They just ask you to solve the exponential function, exponential equation. We find that in order to make n equal to 4, t should be negative 5, but however, t is restricted to be 0 to 20, and negative time do not have any meaning, so this is rejected. That's why, no, it can't be 4. Then go to next part. They are talking about find the first order derivative and the second order. It totally depends on your differentiation skills, but in order to reduce error, we change it to the favorable format, 40, and then the denominator, power of negative 1. If we differentiate both sides, it will give us 40, and then negative 1, power of negative 2, and then don't forget you still need to differentiate what is left. By chain rule, if you think that you can't finish everything in a row or it's really messy, then I suggest you to separate your calculation. Tidy up what in the front first. And then differentiate this, keep it the same. Multiply natural log 3. And differentiate the index by chain rule, we have negative 0.2. So tidy up one by one. We have positive 8. We have 3 power of 1 minus 0.2t. We have natural log 3. And we have 3 power of 1 minus 0.2t plus 1 power of negative 2. If you want to make it a little bit more good looking, you may extract 3 and multiply to 8. It looks slightly better. For the final answer, this is our final answer for dndt. Then I will express in terms of positive index. But however, when I continue to differentiate it, if I consider the second order derivative, I will just focus on this format. Write down the common factor 24 and natural log 3, so it won't affect our calculation inside. Differentiate the first one. Keep the second factor. Second term right in the second row. Keep the first factor, differentiate the second one. It's troublesome calculation, so no rush. Try to tidy up your calculation first. Make your hand busier than your brain. We calculate all the constant first. Negative 2, natural log 3, negative 0.2. So we have positive 0.4 natural log 3 here. And then we have this item. We also have one more. And also the trouble bracket. To extract common factor, we are going to extract this common factor and also this item. But we choose the least power, so we will extract power of negative 3. See what we left. This is left, and also this one, power of 1 will left. So negative 0.2 natural log 3 times 3 1 minus 0.2t plus 1. The second bracket, we have this factor and this factor left. So we have positive 0.4 natural log 3 times, and then 3 power of 1 minus 0.2t. If you combine them, you will find that there is like term and then 0.2 natural log 3 times of this. And then we have minus 0.2 natural log 3. Finally, you find that there are still common factor, or if you realize it, you may extract it in the first step, but it will increase your workload, so it depends on your own habit. We extract the common factor 0.2 times 2.24, we will get 4.8. Natural log 3, power of 1 here, and also power of 2 here. And in final answer, there shouldn't be a decimal in the fraction form, so you change it to 24 over 5. This part is slightly different from the marking scheme. The marking scheme here is 8, while the 3 is still kept inside here. It's just because I think it's more comfortable for me to handle 3 power of something only. The last part, we need to analyze how the rate change during the experiment. So to understand how this function is changed, we consider the derivative of this item. That means the second order. Then we know that is that going up, stop, going down, something like that. That means we are going to create a table for this. Exactly the same as how we analyze the original function shape. For training points, we are considering the derivative of the function that we want to investigate equal to 0. So 24 is constant, this is constant, this never equal to 0. So the key point is whether this factor is 0. 3 power of 1 minus 0.2t minus 1 equal to 0. Equal to 1. 1 that means 3 power of 0. So 1 minus 0.2t is equal to 0. T is equal to 5. 5 is within our given range between 0 and 20, so it's fine. And then we are going to write down the table to show how it's changed. The input, the domain is cut by a point t equal to 5. So left hand side we have t between 0 and 5. And also right hand side we have t between 5 and also 20. Beware do you include the equal case. So we are talking about derivative of our function that we need to investigate. This part, when t is smaller, 3 power of something become bigger, and which is big enough to minus this, so this is positive. When t become larger, then this part will become smaller and not enough to minus 1, so this is negative. Or if you do not get used to this method, you just put some value between them. For example, like 2 and then c, this will give you positive or negative. And I don't need to consider other factors is because I know all other factors must be positive. Now the graph, the table, show that this function first increase and then at t equal to 5 is become maximum stop and then go down again afterward. The function we are considering will increase when t is between 0 and 5. Is attain maximum when t is equal to 5, and finally dn dt decrease when t is between 5 and 20. So that's how you finish the question. It's not difficult at all, but you need to have a very strong foundation in differentiation skills, and also you need to know very clearly what you're calculating. The key point is you need to identify what is the original function that you need to investigate, and don't just memorize the procedure.